This is one of the Educate.ie samples, sample 5, paper 2, question 1, and it's an area and volume type question. We have two circles with a drive belt around it. They tell you that the radius of each wheel is 8 centimetres and the distance between the two centres is 20. So that obviously means that also the distance between the two contact points on one side is also 20, and likewise on the other side. So to work out the length of the drive belt, what we need to do is break this up into two sections. We've got the two semicircular arcs at either end, and I'm sure you can realise those two semicircular arcs create a circle, which is a radius of 8, and we want the circumference, so we're going to use 2 pi r, and we get a distance of 16 pi in centimetres, which works out, when you do 16 pi on a calculator, you get 50.3 centimetres. So that rounds to 50 centimetres. And then we have the two straights, and if you think about it, they're both 20. So 2 lots of 20 is 40, and so my total is going to be 40 plus the 50, which gives me 90 centimetres. Moving on to part B, we have a cylinder, and then we also there's a cone inside there. Now we should point out to you that the diameter is 28 centimetres, so we have a situation where my radius is going to be half of that, which is 14. We have a height of 57. So in terms of working out the actual volume of the cylinder, volume of a cylinder is pi r squared h. So r is 14, so we square that, and the height is 57. And we get a total of 11,172 pi, and that is in centimetres. The volume of the cone inside, well, again, its radius is 14, again, its height is 57, and the volume of a cone is 1/3 pi r squared h. So basically we're doing 1/3 of what we've just worked out, but just to do it the long way, 1/3 times by pi times by 14 squared times by 57. Anyway, when you do 1/3 of 11,172 pi, you get 3,724 pi. Again, that's in centimetres cubed. Now, the key bit to this question is the fact that the cone is cut from inside the cylinder. And if you think about it, the cone is 1/3 of the cylinder. Therefore, what you're left with is 2/3. You should just understand it from the basic understanding of how you can work out the volume of a cone. It's 1/3 of its parent prism. But obviously, if you want to work out the long way, you can just say to yourself, okay, 11,172 pi, and divide that by 3,724 pi, and actually see what's going on. There's 3 lots of cones in there. So if you take one cone out, you're left with 2 left. There's 2 out of 3. Your final alternative method is to say to yourself, well, if we just do a subtraction to find out what we've left with, we end up with 7,448 pi, and you're just working out, okay, what is that as a fraction of the original whole amount? And when you do that, you'll get 2/3. So either way, whichever way you're going to do it, you get an answer of 2/3. Moving on to the last question, we basically have ourselves a quadrant, which is a quarter of a circle. We're being asked to work out the area of this sort of shot put zone. They give us certain information. So, for example, it tells us the radius there is 80 metres. We've got confirmation that it is indeed a right angle. So the key thing here is we're just working out a fraction of a circle, so a quarter of pi r squared. The radius is 80, and we get 1600 pi, which, if you want it in decimal form, is 5026.5, correct to one decimal place, and that is in meters squared. In the second part, we're only interested in this sort of shaded throwing zone, and they tell us the radius is 1.2 meters. They show it's a circle, so therefore the area is going to be just using pi r squared. So pi times by 1.2 squared gives us an answer of 4.52, and it carries on 389, but it's rounded to two decimal places. It's 4.32 meters squared, correct to two decimal places. And lastly, so we're wanting a further area. Now, this question's not actually particularly clear what it's asking for, because it's talking about, firstly, a landing zone, which is this white section here. Okay, you've obviously got the actual sort of shot-putting zone, what they've called the sort of throwing area. Now, it asks then for the total area of the shot-put zone. What do they mean by the shot-put zone? Do they mean the landing zone? Well, in that case, you have to work out that white section. Are they after the entirety of the entire shape? It's not particularly clear. There's two approaches you can take. And what I would say to you, if you have a question like this, you need to be clear about it. You need to sort of explain what you're working out. Now, since it actually talks about the total area, I'm going to take it as the entirety of all of this. We have to be careful, because if we just added the two answers to the last two bits, we'd have a situation where we'd count this area here twice. So what we need to do is we need to think about, okay, what's this outside bit, the bit that's going to be extra added on to the 1,600 pi we got in part one. So if we think about our answer from part two, which was the 4.52, we're wanting 3/4 of that. So if you work out 3/4 of the 4.52, and then add on to that our answer from part one, which, correct to two decimal places, is 26.55. We'll end up with an answer of 5,029.94. That's in meters squared. Now, just be aware that depending upon what value of pi you use, 3.14, and whether when you rounded you create a certain error, you might have something that's slightly different from that. But within a couple of meters squared, it should be 5,029, 5,027, something in that region, depending upon what values of pi and how you rounded. But that is in a sense, the exact possible value.